Hey guys, and now we're going to solve for some applications of differential equations on mixed problems and Newton's cooling law. Now we have a problem here which states a tank is filled with 100 gallons of water containing 2 pounds of salt per gallon runs into the tank at the rate of 5 gallons per minute, and the mixture, assumed to be kept uniform by stirring, was out at the same rate. Find the amount of salt at any time t and determine how long it will take for this amount to reach 150 pounds. Now we must remember some of these terms in order to solve this problem. So the 100 gallons of water that contains 2 pounds of salt that goes into the tank at 5 gallons per minute at the same rate it goes out, and the time it will consume in order for it to reach the amount of 150 pounds of salt. So RQ is 100 gallons, and as I told you earlier, the input rate, which or Rin, the input rate is equals to 0 since there's no salt in fresh water. So the R R out the R sorry the R out, or the output rate, is Q over 20. And now that we've established the given values, we can now solve for our problem. So these are the given values. So first we'll write dq over dt, which is equals to R in minus R out. And now we'll just substitute the values in order to proceed to our solution. So R in is equals to 0 minus Q over 20, which is the R out. Now using this, we'll get the forgot dq over dt. So using this, we'll be able to get 2 2q 20 dq over q equals to dt. Now we're able to separate them into different variables. So now using this, we can now proceed to negative 20 ln q equals to d plus c. So now we applied separable in solving this mixed problem. So using the new equation, while solving at time which is equals to 0, and q, which is equals to 100. So we just have to substitute the value in our equation. So negative 20 ln q equals to substitute the value of t, which is 0, plus c. It will equate to c equals to negative 20 ln, substitute the value of q, which is 100. So we got the value of c. Therefore this value will be equated to our original equation, which is negative 20 ln q equals to t plus c. So negative 20 ln q equals to equals to equals to t equals to t minus negative 20 ln 100. Oh, sorry. ln 100. After this, we can now simplify this equation. So t is equals to positive 20 ln 100 over q. Then T over 20 equals to ln 100 over Q. Now, this value can be multiplied to E to be simplified. So E times T over 20 will become E raised to T20 equals to E raised to ln 100 over Q. Q. Now we can cancel out E and ln, so it will be E raised to T20 equals to 100 over Q. So this is our new equation. Now using this new equation, we can transform it into Q equals to 100 over E T 20. Then uh, uh, Q Q is equals to 100 E 100 E negative T raised to 20. We just raised the denominator, so the exponent will become negative. So this new equation will be solved by letting Q is equals to 150 pounds and at find the time. Oh, at, yeah. So using the equation, Q will be substituted by 150 equals to 100 E negative T over 20. So we'll divide both sides by 100. So the remaining value will be 150 over 100 equals to E negative raised to negative T over 20. So next we'll uh, divide we'll multiply this value to ln to cancel out E, so the remaining value will be ln 150 3 halves. We simplify the 150 over 100. 3 halves equals to E raised to T over 20. Oh, sorry, I missed it. The E is already cancelled, so the remaining value will be ln 3 over 2 3 halves equals to negative 20 over negative T over 20. So we'll rearrange the equation. 20 ln 3 halves equals to negative T. So the value of T is equals to negative 8.109 minutes. Now that we got the value of T, we can now surmise that therefore it is impossible to have the tank at 150 pounds of salt. And it also states that if time is greater than 0, then the amount of salt will be greater or equal to 100. Thank you for watching. See you again at the next video.